Functions. Okay, so this video is all about function review, and to start that off, let's talk about domain. Right, so the domain is a set of all x values, all the input values you could do, and we're going to talk about how to find domain in lots of things. So first, if you're doing domain with the graph, just look at the x values and you go left to right. But the general way to do it is with an equation, and the way we do that, the way you want to think about domain is what numbers can you plug in. Domain is all about what numbers you can plug in. Right, because it's the input values. And the best way to think about that for when you do a domain of like an equation is to think about what numbers you can't plug in. Like that's right. So domains are numbers you can't plug in. That's a lot of numbers. So we do the conjugate of that. We don't think of numbers you can't plug in. So it's a little easier than it sounds. Like division. Well, remember you can't divide by 0. So if you ever see a fraction, your domain is always whatever the denominator is cannot equal 0. That would be the domain. So for example, if I give you 3x over x plus 2, you go, okay, x plus 2 can't equal 0 because I can't divide by negative. By 0, I should say. And x can equal negative 2. That would be your domain. So that's fractions. Next one is square roots. If it's a square root, then you can't have a negative. Can't take square root of a negative number. So your domain is x has to be greater than or equal to 0. That's the basic domain of it. Let's do a quick example. Right, if I said what's the domain of f of x equal to radical x minus 5 plus 1. I don't care about that at all. It's all about this part right here. The thing is that the radical cannot be negative, so you do this. Then you solve it. X has to be greater than or equal to 5. That's your domain. Right, so fractions, right, you can't divide by 0. Stuff we know already. So that's your domain. What the denominator is cannot equal 0. Square root, you can't have a negative square root. So that's your domain. For logs and natural log, domain is the domain of natural log and log is x has to be greater than 0. That's the domain for logs and natural logs. Right, you can't take a log of 0 or negatives. Logs and natural log are the same domain. X has to be greater than 0. So again, if I did a quick example here, force space at a premium right now. If I was like, what's the domain of natural log of x minus 4 plus 1? Again, I would only care about this part. That has to be greater than 0. Can't have no negatives. And that, and the x equals 4. So that's basic domain. Everything else besides 10, which we really won't focus on, is all real numbers. Right? It's all about because there's no issue. If I give you what's the domain of x squared plus 1, I could plug anything I want into there. So all real numbers. If I give you what's the domain of sine of x minus 3, I could plug anything I want to sine. There's no issues. All real numbers, right? So only time we have issues if there's a fraction, if there's a square root, or if there's a natural log or log. And some values of 10, but we're not going to care about those right now. So that's domain, right? It's all about numbers you can plug in. And again, the key thing to keep in mind is fraction you can't divide by 0. Square root has to be greater than or equal to 0, no negatives. And the newest one is kind of natural log and log. Has to be greater than 0 if you read that. So that's domain. How about range? Well, the easiest way to do range is just look at the graph. We'll see another trick they do later on, but generally the range of the y values, it's a lot harder to figure out what the range is by like having the graph. You have to think about it logically if you have an equation. So the best thing to do, just look at the graph. Like, okay, my range is from here to here. Let's say 1 to infinity based on the graph, right? The range is the y values. So look how your graph is going up and down. That's the easiest way to find the range. Again, we'll talk about a little trick that Abby does to do a little later. Okay, so now we know what domain and range are. Next up, if I give you a function, how do we do some operation with the function? First one here, g of 5/2, right? Well, you look for the g function, you just plug it in. That's what that is, right? That means plug in That's x, and you're trying to find the y. So plug it in. 4 to the 5/2. Remember, the trick to doing this, guys, is always do the bottom number first. That's a root, and you want to do that first. You do the square root of 4. Then we're going to take that to the 5th. Square root of 4 is 2. 2 to the 5th is 32. So that's a trick to do fraction powers. Always do the root first, and then do the power. So that's that one. Another thing Abby loves to ask you is a composition function, f of g of -2. Another trick to doing these is to do the inside first. I figure out what g of -2 is. Plug it into the g equation, 4 to the -2. Remember, negative power flips it, 1 over 4 squared, also known as 1 over 16. So now I know g of -2 is just 16. So what's left over? Well, h of 16. Oh, 1 over 16, sorry. H of 1 over 16. So that's going to be 1 over 16 squared minus 1. I'm going to pretend that that's my answer. Because otherwise I have to figure out what 1 over 16 is, blah, 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 minus 1 over 1, which is common denominator. But that's the idea, right? Figure out this first, plug it in, get your answer, then plug it into the answer, then plug into the other one. The next one, right, it's a fancy symbol. Some of you guys confuse this for derivative. It's not. That's the inverse symbol. We'll talk about this more later, but for now, inverse just means switch x and y and solve for y. Right, in the inverse, you literally switch x and y. So here's my f function. Here's x. F of x is y. You switch them, so you get x equals 2y minus 3. And anytime we do that, it's just the letters. So like if I did the inverse of this one, I would switch x and y. Here's my y. So it'd be x equals 4y. Right? If I was inversing this one, here's my y. You switch it. Right? So it's just the letters. You don't switch anything else, just letters. And then from here, you just solve for y. Plus 3 divided by 2. X plus 3 equals 2y divided by 2. X plus 3 over 2 equals y. That's a 2. So that's the inverse. Right? You just switch x and y, solve for y. Now this one, this is the one that pisses me off the most. So look at it says h of x equals 0. Equals 0. It's not this. You're not plugging in 0. You're sending it equal to 0. It can't be more clear. So hey, here's your h of x. Say equal to 0. Well, h of x is this thing. So x squared minus 1 equals 0. Notice again, I mentioned it equals 0. And then you just solve it. So you could factor, or you could add 1 to both sides and take the square root. Either way is fine. X equals plus and minus 1. So that's again, very big difference between this and this. That thing I crossed out, right? You said equal to 0 and solve. So next with GDC skills, we actually have a whole video on this, so I'm not going to really go into it. But a big part of it, using calculator on the test, is to know how to graph it. Just copy down the graph. And a big part is how to solve it. We've been doing this a lot lately, right? You set y1, do y2. You have two graphs that cross, and you have to find the intersection point. Anyway, but we'll talk about that more later. Let's go to family of functions. So these are just all the basic ones you should know, right? Y equals x, or y equals x plus 0, right? That's what the graph looks kind of like this. And then y-intercept is 0. Slope is 1 over 1. So it's that effect, right? A linear line. Next one's a parabola. So it's something to this effect. 1 over x is the reciprocal function. They did this a lot in algebra 2. Looks kind of like this. Ooh, a little off. There should be an asymptote right here and an asymptote right here. So it's into that effect. E dx, exponential function. You cross at 1 and asymptote right here at 0. And it goes up. Natural log. Very similar to log. Same graph actually. But asymptote is at 0 right here in this way. And you cross at 1. And it looks like this. Alright, so these are all the basic graphs you should just know for the IB test. Again, just all these. Transformations, thing we always talk about. Inside opposite, outside follow, right? If here's your basic graph, I don't care what it is. That's your basic graph. Inside, and on the inside affects the x values. When I say that, it's a shorthand for me saying left and right. right? And x goes left and right. So that affects the left and right. And you do the opposite. So I'll move c units to the right. So I'll be going this way. On the outside, that affects the y value. So I say x outside y, which I mean goes up and down. And you follow what it says. And again, it also works to just like a point. So let's say I give you a point 2, 1. And I said, hey, we're going to do this to it. What you do is you do the same thing. You go, okay, inside opposite. So on my x, I'm going to go plus 3. So you get your point, you just add 3 to the x value. Outside is y. So on the outside, on the y value, you're going to go plus 4 because you follow. So on your y value, you go plus 4. And you get your new point, 5, 5. That's the way it works. Stretch and shrinks. Oh, I guess the only thing we really care about stretches. If it's on the outside, notice again, outside, it affects the y values. And you follow. So does that mean if it's a number bigger than 1, it's a stretch, it's a bigger. If it's less than 1, it's a shrink. We don't care about the negatives. I'll talk about the negative in a second. So let's get my same point here, right? And if let's say this time I gave you 3f of x. Well, you do the same thing. You go, okay, that's on the outside, so it affects my y value. So multiply the y value by 3, and you get 2, 3. That's all it is. Just get your points and do what it tells you to do. Horizontal stretch is the only one that's kind of funky. So horizontal stretch is on the, again, notice that's on the inside. So it affects your x. And you do the opposite. So what I mean by this one, this one that's a little funky. Let's say I gave you f of 2x. Well, the opposite of multiply by 3 is divide by 3. So like right here, they say you're going to multiply by 1 over 2. So let's get my point again, 2, 1. I see the 2x on the inside, I do the opposite. So I divide by 2 or multiply by 1/2. Just the x, and you get 1, 1. That's the whole idea, right? Anything on the inside affects the x value. If it's being added or subtracted, you add or subtract. If it's being multiplied or divided, you multiply, divide. And then on the outside, it affects your y value, so due to the y values. Inside is opposite, outside is follow. And I mean opposite operation. So let's look at this one. Consider a graph of x shown below. On the same grid, sketch the graph of this. So let's break down what's happening here. Right, on my x, you're moving it left 3, inside opposite, so left 3. Or if you want to think about it, minus 3, right? On the y, look what's going on. So there's only one thing on the outside, it's multiplied by -2. So we're multiplying by -2. Or there's a vertical stretch of 2. There's also a flip though. The negative is a flip, and we'll talk more about that in a second. So, how do I do this? Well, a couple ways you can do it. One way I always like to do is just pick points. So that is -1, 2, 3, 4, 4, 3. So I got -4 and 3. And then I have this one right here, -1 and -3. And then we could do that one. Is that 1, -2? And then we have this one right here, 3 and 1. And then let's just do the thing we talked right here, right? So if I'm going to graph that, I'm going to go left 3 my x's, so all your x's is subtract 3. Again, you can also just move it left 3, that also works. And then on your y's, this is a little tougher one, right? You're going to multiply by -2. So I'm going to multiply all these by -2. Now, it's tougher to do visually. Like on here, how do I multiply my y? So you go from there to normally 2 higher, but then you guys make it negative. So you'd be like, that'll be 2, but then you got to flip it. So for me, it's just easier to do the math on the numbers. So I get -4 minus 3 is -7. 3 times -2 is -6. So -7. 1, 2, 3, 4, 5, 6, 7. -6. Ooh, I wish I had markings. 1, 2, 3, 4, 5, 6. About here. -4 and 6. So 1, 2, 3, 4, and I'm going up to 6. 1, 2, 3, 4, 5, 6. I'm sure watching me count is super entertaining. 1 minus 3 is -2, and then 4. -2, 4. And then here, negative 3 minus 3 is 0. 1 times negative 2 is negative 2. So 0, negative 2, that's the easiest one. And then you gotta connect them. Oh, it's probably the hardest part for me right now. Something to that effect, less curvy. But if you see, look what it did, right? It flipped it upside down, and then it stretched it by 2, and then moved it left 3. Again, for me, it's easier a lot of times if it's like multiplication, just to do the numbers, do the math, right? What's happening to my x, what's happening to my y. That's what the next one does also. The point 3, 1 is on f of x, which write the coordinates of the point image on A. So basically saying, hey, we're going to do this to it, right? You have 3, 1, do this to it. That's what that's saying. So remember, what does each thing do? On your x, remember inside opposite, we're going to divide by 2 or multiply by 1/2. On your y, outside follow, you're going to go minus 3 or down 3. So all you have to do is do that to your point here. On your x, divide by 2. On your y, subtract 3. 3 divided by 2 is 3/2. 1 minus 3 is negative 2. And that's it. That's all it is. The next one. The function g of x equals negative f of x minus 3 plus 1. Give a full geometric description. So I just want you to say what's going on. So you can do a couple things. First one, notice this negative right there. If it's a negative on the outside, we didn't talk about this. That's on the outside is called a vertical flip. Right? It's on the outside. Outside's y. It's going to flip vertically. Some people call it an x-axis flip because it flips across the x-axis. That also counts. I like to think about it, it's on the outside though. Outside is y, which is vertical, right? Y, vertical, so it's a vertical flip. If the negative's on the inside, then it's on the inside's x, so it's horizontal. So horizontal flip. So it's a flip left and right. So like the one I did here, right, is a negative on the outside, so it flipped up and down. If I put a negative on the inside, it would flip this way. So I would say it's a vertical flip. And then you could just say, oh, it moves inside opposite, moves right 3 units. And then outside follow, up 1 unit. And that's it. Now, sometimes your book does it in a vector notation. So they'll write this in a vector notation. So how do they do that? Well, if you think about a vector, it's like x, y. So the book would say, the IB test would say, it moves 3 because it's a positive, right, inside opposite, and then 1. So it gets moved by the vector 3, 1, right? Because x, y, inside opposite, positive 3, outside follow 1. The function f of 1/3 give a full geometric description, right? So what's happening here? Inside x opposite. So now you're dividing by 1/3, but the opposite of that would be multiplying by 3, right? Multiply by 1/3, what's the opposite? Multiply by 3. So you just say this is a horizontal stretch of 3 units. And there you go, done. That's all it is. Now let's talk about some general concepts of graphing. Remember, anytime you want to find the x or y intercepts, you just do the opposite, right? Y intercept, you set x equal to 0. X intercept, you set y equal to 0, if there is any. That's all it is. Now again, you could always get none. Like you could try to solve it and you can't solve it, and you get no x or y intercept. So, and that leads us to quadratic functions. Now, quadratic functions, there's lots of different ways to write it. So let's talk about all the forms. The first one is a vertex form. So you have it like this. This form makes it easy to do a lot of things. First thing is how to find the vertex, right? Inside opposite, outside follow. So let's say I gave you y equals 3x minus 4 squared plus 5. Just from that, I know what the vertex is. It is opposite 4, follow 5. Done. And I could graph it super easy. Just go to my vertex, 4 or 5. This is a positive A, so that means it opens up. And there's my graph. Right, so A is kind of like the slope, that's a word. Positive goes up, negative goes down. Right? So super basic vertex form. And then there's what we call factored form. What this does, this helps you find your x and y, your x-intercepts. Super easy. Right? To find x-intercept here, it's actually a lot of work. You gotta like simplify it out and then find the x-intercepts. Here, it's already factored for you. You're done. So my x-intercepts are just P and Q. So as an A there, right? It's actually not that bad to find the vertex here. Let's show you an example. Let's say I give you this 2x minus 1 x plus 5. Right? So I know my x-intercepts are at 1 and negative 5. So let's have a graph. I go 1 and negative 5. Positive 2, right? Opening up again. So how would I find my vertex here? Well, it's always the middle point. So if you have your x-intercepts, you just add them up and divide by 2. So you have your x-intercepts, P plus Q divided by 2 is your x and your vertex. And in this case, it would be 1 plus negative 5 divided by 2, which is negative 4 over 2, which is negative 2. So your x and your vertex is negative 2. So my vertex, my x is negative 2. I still got to find the y. And also I want to point out, right, your x and vertex is also known as the axis of symmetry. There's a formula for axis of symmetry in your formula sheet. We'll talk about that in a second. But if you have the x, remember then to find the y is the easiest thing in the world. You just plug it into your equation. So if you want to find this, you have this. Just plug in negative 2. You get 3 times negative 3. So you get negative 9, negative 18. Alright, so that point would be negative 2, negative 18. And now, by the way, you could easily put that in vertex form, right? Vertex form was this. To put in vertex form, all you ever need is a vertex, and you have it now. This is negative 2. This is negative 18. You're like, oh, I don't have my A. It's the exact same A as this A. 2. So you have everything you need. Putting vertex form has always been easy. Just find the vertex and you're set. So, right, very easy to go from factored form to vertex form. Just find the vertex, plug it in. So that's factored form, right? Factored form is good because it gives you the x-intercepts right away, which is usually the hardest thing to find. So we like factored form. Vertex form is good because it gives you the vertex right away, which makes it super easy to graph. And the final form is called standard form. We generally don't like standard form. Standard form is a standard form. It's like that. What's it good for? Well, it does give you the y-intercept. It's super easy because you can plug in 0. Other than that, it does give you the axis of symmetry. So in your formula booklet, they tell you this. And that's your axis of symmetry. So x, since I wrote over it for some reason, x equals negative b over 2a. That is the axis of symmetry. It is in your formula sheet. And remember, axis of symmetry is also the x and the vertex. That says x and vertex. So once you have the x and the vertex, which you can find very easily, then you can find the y and the vertex by plugging it in. Right? So a lot of times they're going to give you this because they want you to graph it or they want you to put it in vertex form. So let's do that. Let's do an example real quick. 2x squared plus 4x minus 1. Right? Let's say I give you that. And I want to put it in vertex form. I want to put it in this form. Now there's 2 ways to do it. One way to complete the square. Yeah, most people don't like that way. The other way is this, find the vertex. Well, first thing as always, this is A, right? A, B, C. So my A is 2. That part's done. All we gotta do is find the vertex now. We have a handy dandy formula. So x equals negative b over 2a. So negative 4 over 4, negative 1. So my x is negative 1. Again, if I have the x in the vertex, which is my h, to find the y in the vertex, you just plug it in. So y equals 2 times negative 1 squared plus 4 times negative 1 minus 1. This goes first. That's positive 1. 1 times 2 is 2 plus negative 4 minus 1. It's negative 3. So that's negative 3. And now I have my vertex. Right? So it's easy. So to go from standard form to vertex is pretty easy. If you want to find the x-intercept, it's a lot tougher. You gotta set equal to 0 and either factor or use a quadratic formula. But that's the general idea, right? So there's standard form, which no one really likes, but it does make it easy to find axis of symmetry and the x and vertex. There's factored form, and there's vertex form. And again, if you want to find the x-intercepts in this form, you just set equal to 0, and then usually either factor or quadratic formula. Okay, let's do some examples. First example, let's convert this into this form. That's a vertex form. right? So again, notice you already have your A. And actually, so we don't kill each other, let's make this an 8. Otherwise, it's me ugly. And I don't want to bring out the calculator for every little thing. So, right, this thing that we just did right now. So if you want to put it in this form, hey, they already give you the A. All we got to do is find the vertex. So x equals negative b over 2a. Here's my A, here's my B, here's my C. So negative 8 over 2 times negative 2. Negative 8 over negative 4. Or just 2. So my P right there is just 2. My X, my vertex. You want to find the Y? You plug it in. So Y equals negative 2, 2 squared plus 8 times 2 minus 11. Now remember, this goes first. So that's 4 times the negative 2 on the outside, so negative 8 plus 16 minus 11. So 8 minus 11, negative 3. So there you go. You filled that out. Don't forget the square right there. A lot of people forget that for some reason. So that's how you go from that form to a standard form to vertex form. Next one, graph alongside is a parabola with x-intercepts at -1 and 5. Write it in the equation in this form. So again, keep in mind we know what x-intercept is. So -1 and 5. Right? Those should be this thing right there. So one of these is -1, one of these is 5. Doesn't matter which one's which. So I have this right now. And write down the values of m and n. I should write that right here. So one of them was -1 and one of them was 5. So now there's a minimum at p -36. Find the value of p. So here's the key thing about this. The minimum, so they're saying some value p -36. It's around there. Awesome job as always for Goso. So the minimum is at p -36, right? There's p and -36. The key thing is to understand what that is. That's the vertex, right? The min and max only happens at the vertex. So they're saying, hey, the vertex is at p -36, find p. Well, we know how to find the x on the vertex, right? It's halfway between our x-intercepts. So all I gotta do is go -1 plus 5 divided by 2. Right? That's how you find the x on the vertex if you have the x-intercepts. So you're gonna be 4 over 2 or just 2. So p just equals 2. My vertex is at 2 and -36. And now, so 2 -36, I might need that right now. And now, find the equation probably giving your answer in the form of this. So now they want me to find what a is. Now it's a little easier than you think. I have a point right here. I have an x and a y. I still gotta find my a. So all we do is plug it in. So -36 equals a 2 plus 1 and 2 minus 5. Right? That's all it is. I have a point. You can plug it into the equation you have right now and find your a. So -36 equals a times 3 times -3. So -36 equals -9a. Divide by -9, a equals 4. So I have this. Y equals 4, x plus 1, x minus 5. So now, if you notice, that's still not in the standard form that everybody hates, me included. So what we do next is we distribute. That's all you have to do. So multiply these first. X squared minus 5x plus 1x minus 5 times it by 4. Let's simplify this inside first, actually. And now times it by 4, and you get y equals 4x squared minus 16x minus 20. And there you go, to 4. Right? So that's the idea. Keep in mind, guys, right? If you have your x-intercepts, it's really easy to find the vertex. Just add them up and divide by 2. It's just the average, right? It's always halfway in between. So add them up, divide by 2. If you have a point and you're trying to find a missing value like a, just plug the point in. Key things. Okay, a little bit more on quadratic equations. First, how do we solve quadratic equations? Remember, the way you solve a quadratic equation is always the same thing. You set equal to 0. Super important. Don't just split it up. I hate when people give me this. And they're like, oh, they'll factor or something. Oh, they'll do this. I know it doesn't work, but they'll do this and they'll go, oh, we'll split it. I'm like, no. Set equal to 0 first, and then you could factor. Or if it doesn't factor, quadratic formula. The quadratic formula is in your formula sheet. Right, so if you have a quadratic equation, either set equal to 0 and factor it. That's if you can do by hand. Set equal to 0 and factor it. It's like this one. Right, set equal to 0 already. Nice. I could factor or I could do a quadratic formula. This one actually does factor. It's a little fancier. Multiply those two together. Negative 10x squared. Find the combination that gets you 10 but adds to get 3. That is 5 and 2. So negative 5x and positive 2x. Actually, I'm going to switch it. Let's make it a little tougher. So 2x squared. Right, once you get the middle, once you get the combination, plug it in from the middle. So bye-bye 3x plus 2x. I'm going to switch it this to make it a little bit tougher. Minus 5x minus 5. Right, all I do is plug this in for the middle right there. Now you can factor by grouping, my favorite type of factoring. Always bring down the middle sign. That's why I did this. So they have a 5 in common. Negative 5x divided by negative 5 is just x. Negative 5 divided by negative 5 is a positive 1. Hey, these match. X plus 1, 2x minus 5 equals 0. Now if you're going to solve it, right, just split it. And x equals negative 1. And then x equals plus 5 divided by 2, 5 halves. Right? That's how you solve a quadratic. Set equal to 0. And then either factor or use a quadratic formula. That's it. Factor quadratic formula. Right? I factored. It's a fancy factoring I did there. But you got your answer. And you're gonna know. You need to know how to factor. Other way you can do it. If it's paper 2, you can use a calculator. I keep on doing that. All you have to do is graph it. Y1, Y2. We're going to talk about this more later. But you can use your calculator to graph it. And then figure out where they intersect. So you go like on y equals, again, alpha y equals x squared plus 1 over x plus 1 equals 3. Just figure out that cross. Now it's a little tougher if that's not 3, if it's like 500, then you get to fix your window. But if you do this, look at, there's 2 answers there, that and that. So you're gonna go second, calculator, intersects. All you gotta do is get a little closer to the one right there, so it don't have to be right on it. Hit enter a couple times, and I get 0.562, 3 sig figs. Do the same thing to the other side. Find the intersection. Now move over there. Now there's 2 ways to do it. You can also press up, and it goes to other graphs. So it's a little easier to see. Get close to it, hit enter a couple times, and 3.563 sig figs. So there you go. Like, that's how you do your calculator, right? Sometimes you have to work with the windows, but in general, that's the idea. If you can do this by hand, you just multiply both sides by the denominator, and you get something like this. Right, and then we distribute. And then we set equal to 0, because like I said earlier, set equal to 0. So minus 3x minus 2 equals 0. Right, so we get, it's kind of ugly to see, but there we go. We get that. We get x squared minus 3x, was bugging me, equals 0. And then this one does not factor, do the quadratic formula. You saw that our answers are ugly. So you do A, B, C, use a quadratic formula in your formula sheet, and get an answer. Okay, so that's how you solve quadratics, right? Set equal to 0 and factor. If you have a calculator, just y1, y2. Next up, discriminant. So this is something they tend to ask a lot on IB tests, because it's like a little special for the IB tests. And that's this. Now they do give you this in your formula sheet. This is the discriminant. They'll say, hey, the discriminant. They usually don't just straight out say, hey, we're using discriminant. They'll talk about the number of roots, and that's kind of the key, the number of roots. If they mention the number of roots, then they talk about the discriminant. So here's the discriminant, b squared minus 4ac. It has to do with our quadratic formula there. It's a thing underneath the radical. And that's kind of where this comes from. Because if that thing underneath the radical is negative, well, that means you have no solution. It's all imaginary. So if the discriminant's less than 0, then there are no x-intercepts or solutions. Now, if that thing's 0, that means it goes away, and all you have is negative b over 2a. So you have one answer. So if that thing's 0, then there's one root. Sometimes it's repeated. There's one repeated root, or there's one solution. So basically, right, If that is negative, there's no solution, no roots. If it equals 0, there's one root. Sometimes it could be a double root. Sometimes it's a double root. Or it's the same root, right? And then if it's positive, that's the normal one. You get plus and minus stuff. Then there's two solutions. And that's the gist of it. Again, they give you this in the form of a sheet. They don't tell you this. You're supposed to know that. You're supposed to know, hey, it's the square root. So thing like the radical. So if it's negative, no solution. If it's 0, it goes away. There's only one solution. It's a double root. And if it's positive, there's two solutions. You have to know that yourself. So to get something like this, here's an example of what they mean. The function f of x equals x squared minus 5x plus 2k has no x-intercepts. State the possible values of k. So notice they didn't mention discriminant. You gotta know, wait, they're talking about the number of x-intercepts or number of roots. That's discriminant. And you gotta go, okay, so I know this equals b squared minus 4ac. Right? And then here's my a, here's my b, here's my c. Now, no x-intercept means there's no solutions, so it's this one. You're gonna set this less than 0. So let's get my discriminant out. Less than 0, right? Because that's what it said, no x-intercepts. So plug everything in. Right, that's a 1 right there. And you plug in the 2k. Solve it. 25 minus 8k is less than 0. Solve it. Add 25 to both sides. Subtract 25 from both sides, I should say. Divide by negative 8. K is greater than 25 over 8. And that's the simple idea. If you understand this, if you can remember that, oh, less than 0 means no solutions, equals 0 means one repeated solution, and then greater than 0 means two solutions, then you just gotta, anytime they mention the number of solutions, you gotta use a discriminant and set it up and solve. Okay, almost done here. Next up is inverses. Now we talked about this before, how to solve it, right? Inverses means switch x and y. That's all it is. But in a graphical sense, that's what I'm talking about here. In a graphical sense, all you do is flip it across the y equals x line. That's the inverse. If they want you to graph the inverse, you switch it across this line right here. Y equals x. Right, y equals x plus 0, if it helps. Right, so what two things are inverse to each other? Well, e of x and natural log of x. They're straight out inverses. So you do that, do that. Sometimes it's hard for me to flip it across this line, so what I do is I just literally do what it says right here. I switch x and y. If you see here, 0, 1, you switch it to 1, 0, and then you graph it. It'll do more points than that, but that's the general idea. But that's how you find an inverse. If they want you to graph an inverse, just switch it across this y equals x line. So there's an example. I'm going to do one here. Oof, that's the wrong notation. There we go. I want the inverse. Right, so I'm going to switch it across this line here. Not my best line. So the way I do it, because again, I suck at doing that, I get some points. So I get these points like right here. Those points are 0, 0. And 2, negative 4. And let's say 0, 4, 0. I get some more, but that's the general idea, right? That's my function f of x. So my inverse function, you just switch the points. I mean, literally just transpose them. So 0, 0. That becomes negative 4, 2. For some people, so for some reason, people like negate. I don't know what you're doing. Just switch them, guys. Just keep it easy. Just switch them. So 0, 4. So that's my inverse graph. I just got to plot those points and graph it. Let me do that in blue so you can really see it. Right, so 0, 0 still there. Negative 4, 2. And 0, 4. And you want to go the same order. Some people mess this up. They forget how to connect it. Same order you went, right? You went down this way, connect the same order. So 0, 0 connects to negative 4, 2, and negative 4, 2 connects to there. So something to this effect, right? Not my best graph, but that's the idea. You flip it across there. Again, that's the way I do inverse, because I can't. I'm not an artist, as you could plainly see. The next one that we have, I want to get back to these. Given f of x, graph f negative x. Remember what I mentioned how that does? That's on the inside, so x. So x means short half percent, it moves this way, so it's a horizontal flip. So you can flip it horizontally, so it's gonna look kind of like flips across here. So it's gonna look like this. That stays and goes like this, kind of like that. Again, not an artist. Another way to do it, if you want, you could get points again. 0, 0. Let's go 4, 0. And what does that do? It divides your x by -1. Right? So you divide your x values by -1. So you go, okay, divide this by -1, divide this by -1, and you get 0, 0, and -4, 0. Which is why I got those points there. This one, notice the negative's on the outside. Outside's y. Right, so it's going to flip on the y up and down. So it's a flip like this. We call this a vertical flip. Right, so it's a flip up and down on your y. Right, horizontal flip up and right, vertical flip up and down. So it's be kind of like this. Oh man, I can't draw on this thing. So that's the idea. Again, also you can do it with points. We have the point 0, 0. We have the point 0, 4. Alright, what's this say? It wants you to multiply your y by -1. It's on the outside follow. So just get your y values, multiply by -1. And you get 0, 0 again. And you get 0, -4. You know, it would help if that was the actual correct point, 4, 0. There we go. And you get the point 4, 0 again. So nothing changed there. Let me look at this point instead. 2, -4. Multiply that by -1, and you get 2, 4. There we go. That moved up. Right. So that's what you do flips, right? Flip on the inside is a horizontal flip because inside's x, so you flip it left and right. Or if you're not good at that, you can just divide your x's by -1. Negative on the outside is a vertical flip, so you can flip it up and down vertically. Or if you're not good with that, you just multiply your y's by -1. Again, almost done. Last couple things, we'll do a couple more inverses. These are just a little more complicated. So again, this is notation for inverse. So the reason we're doing this is because it's a little more complicated. So let's find inverse here. So here's my y, here's my x. Remember, inverse means switch x and y. So you're going to be x equals natural log of 2y minus 5 plus 1. So I get y by itself, right? It's a natural log problem. So let's try to isolate this natural log. So subtract 1 from both sides. X minus 1 equals natural log of 2y minus 5. Remember the way you get rid of natural log, you take the e of both sides. These cancel, you get e to the x minus 1 equals 2y minus 5. Then from there you just add 5 and divide by 2. So ex minus 1 plus 5 all divided by 2 equals my y. And that's the inverse, right? Just switch x and y, solve for y. Just want to do a little review on logs and natural logs. Right here, exact same thing. Here's my y, here's a y. Here's an x, switch them. I don't know why that y looks so funky. X equals 2 to the 3y minus 5. Again, let's solve for y. You gotta isolate it, so let's get this by itself. So it's add 5 to both sides. You get x plus 5 equals 2 to 3y. Now, the y's on top there. The only way to solve an exponential problem is you take the natural log of both sides, right? If the bases don't match, take the natural log of both sides. So these cancel and you get natural log of x plus 5. Those don't cancel, sorry. Oof, what was I thinking? This moves to the front is what I meant to say. Oh man, that's embarrassing. So you get this. That's not an e. Natural log e cancels. That doesn't do anything. So again, but it did bring your 3y to the bottom. So now what we do is divide by 2 and divide by 3. So divide by natural log of 2 is what I meant to say. I get natural log of x plus 5 over natural log of 2 equals 3y. I could also divide by 3, but I decided to take it slow because people freak out. And then here, just multiply by 1/3. And you get y equals natural log of x plus 5 over 3 natural log of 2. If you want, you can make it a little fancy, bring 3 to the top, and make a natural log of 8. You know, not judging. So that's the general idea, right? So that's how I find inverses. That's all functions. Till next time.